Okay, so for this video, we will be discussing the derivative of parametric equations. So when we say parametric equations, so those are equations for which we have a third variable, so which is called the parameter. Okay, so usually we are given with say x as a function of t and y as a function of t. Okay, so instead of y as a function of x, okay, so instead of y as a function of x, so we are given both the variables as a function of t. Okay, so we will see later on examples of those parametric equations. Now, in curve tracing of parametric equations, so what we usually do is assign values for the parameter t, and based on that we can get the values for x and y, and then we only plot the values of x and y in our Cartesian plane. Okay, so but for this video we will be focusing on the derivatives. Okay, so the curve tracing will be your assignment, okay, your review assignment. So for the derivative of parametric equations, so when we have two equations like this where x is given as a function of t and y as a function of t, so what do we get here is the derivative of x with respect to t. Okay, so since x is a function of t, and the derivative of y as a the derivative of y with respect to t. Okay, so this will be f prime of t. The other one is also f prime of t. Okay, so when we are asked to solve for derivative of y with respect to x, so what we use is the chain rule. Okay, so to solve for the derivative of y with respect to x, all we need to do is divide the derivative of y with respect to t by the derivative of x with respect to t. Okay, so from the division of fractions, this will become dy over dt multiplied by the reciprocal of the denominator, dt over dx. Okay, so in a sense it will cancel out dt, then we will have dy over dx. Okay, so basically all you need to remember for the first derivative is this one. Okay, so because it's this simple, okay, in getting the derivative of y with respect to x, so all you need to do is get the derivatives of each equation. Okay, so get the derivative of x with respect to t, get the derivative of y with respect to t, and then divide. Okay, so how about the second derivative? Okay, so for the second derivative, it's d squared y over dx squared. Okay, so still we will be using the chain rule. So for the second derivative, what we do is derive with respect to t the first derivative, which is dy over dx, okay, divided by dx over dt. Okay, so we can cancel out dt, right? Or we can here above we can apply the division of fractions, d over dt, derivative with respect to t of the first derivative multiplied by the reciprocal of the denominator, dt over dx. Okay, so you can cancel out dt, and then this will become d squared y over dx squared. Okay, so for the second derivative, what we need to remember is this. Okay, So that's how we get the derivative and the first and second derivative, okay, of parametric equations. So let's try to apply those in some problems. Okay, so for our first example, so find dy over dx and d squared y over dx squared. Given the parametric equation, x is equal to e raised to the negative t and y is equal to t cubed plus t plus 1. Okay, so for our solution, again, for our first derivative, to get our first derivative dy over dx, then we must divide dy over dt by dx over dt. Okay, so therefore we need to find the derivative of y with respect to t and then the derivative of x with respect to t. So for our derivative of x with respect to t, from here, okay, so if we have x is equal to e raised to the negative t, then therefore dx over dt is deriving this. So from the formula for exponential function, so all you need to do is copy e to the negative t and then multiply it by the derivative of the exponent with respect to the integrating variable. So the derivative of negative t with respect to t is negative 1. So therefore dx over dt is equal to negative e raised to the negative t. Okay, so for the next one, dy over dt is equal to, derive this, okay, derive y with respect to t. So we have y is equal to t cubed minus plus t plus 1. Okay, so deriving with respect to t, so the derivative of t cubed is 3t squared, and then the derivative of t is 1, derivative of 1 is 0 constant. So we have this one. So therefore our first derivative is this. So derivative of y with respect to t is 3t squared plus 1 over dx over dt. It's negative e raised to the negative t. Okay, so therefore we can simplify this. So we can transfer this into the numerator so that we will have a positive exponent. So we can express this as negative e to the t and then 3t squared plus 1. Okay, so this is our first derivative. Okay, so next is the second derivative. So the second derivative, from the formula we discussed earlier, d squared y over dx squared is equal to the derivative with respect to t of dy over dx. So we will derive the first derivative with respect to t and then divide it by dx over dt. Okay, so first one, let's copy the first derivative dy over dx. So that is equal to negative e to the t multiplied by 3t squared plus 1. Okay, so its derivative with respect to t is equal to, so we can use the product rule for this. So copy the first term, so negative e to the t multiplied by the derivative to the second factor. So we have derivative of 3t squared plus 1 is 6t. Okay, plus, copy this, the second factor, 3t squared plus 1 multiplied by the derivative of negative e to the t. So the derivative of negative e raised to t is copy negative e raised to t and then multiplied it by the derivative of the exponent. So So times 1. And then let us simplify. So this will become negative e to the t times, we can factor out actually e to the negative t, sorry, negative e raised to t, so you can factor that out. So what will remain is, for the first term, it will be 60, and then for the second term, it will be 3t squared plus 1. Okay, and then let us rearrange. So negative e raised to t times 3t squared plus 60 plus 1. Okay, so let us substitute that into our formula. So for the second derivative, okay, so dividing the derivative of dy over dx with respect to t, which is this. So let's copy that. So negative e raised to t times 3t squared plus 60 plus 1, okay, over dx over dt. So our dx over dt is negative e to the negative t. Okay, so simplifying that, so negative divided by negative, it will become positive. E to the t divided by e to the negative t. So we have the same base. To simplify, we can subtract the exponent. So t minus negative t, so that is equal to e raised to t plus t, or e raised to 2t, and then 3t squared plus 60 plus 1. Okay, so this is now our second derivative. Okay, so again, the use of the formulas are very straightforward. Okay, so all you need to do is memorize the chain rules for the first and second derivatives of parametric equations. Okay, so for our second example, so let's have this one. So we have find dy over dx, and the second derivative, given that x is equal to t plus cosine of t and y is equal to sine of t. So again, for our solution, for the first derivative, we need the derivative of x with respect to t and the derivative of y with respect to t. So dx over dt is equal to, deriving this, the derivative of t with respect to t, that is 1. Derivative of cosine of t is negative sine t, so minus sine of t. Okay, so next is dy over dt. So the derivative of sine of t is cosine of t. Okay, so therefore, our first derivative, dy over dx, so that is equal to, dy over dt over dx over dt. So therefore, our first derivative is simply cosine of t over 1 minus sine of t. Okay, and then that's it. Okay, so that's our first derivative in less than 2 minutes. So next is the second derivative. So for the second derivative, d squared y over dx squared is equal to derivative with respect to t of the first derivative over dx over dt. Okay, so we have this one, so we will derive we will derive the first derivative with respect to t. So we have, again, so writing here below our derivative with respect to t of the first derivative. So this is quotient. So we'll use the quotient rule. Okay. So denominator multiplied by the derivative of the numerator minus numerator multiplied by the derivative of the denominator divided by denominator squared. So writing first the denominator, we have 1 minus sine of t multiplied by the derivative of the numerator. Derivative of cosine of t is negative sine of t. Okay, minus, copy the numerator, cosine of t multiplied by the derivative of the denominator. So 1 minus sine t, derivative of 1 minus sine t, so 0 minus cosine of t. So negative cosine of t over dx over dt, again is, so denominator squared, I mean. Okay, so we are still here. So divided by denominator squared. So denominator squared is 1 minus sine of t squared. Okay, and then simplifying the numerator by expansion. So this will become negative sine of t plus sine squared of t, and then plus cosine squared of t. Okay, over 1 minus sine of t squared. Okay, so from the identities, we know that sine squared t plus cosine squared t is equal to 1. So therefore, this will become negative sine of t plus 1 over 1 minus sine of t squared. Okay, so for which we can actually cancel out, can rearrange this, right? So negative sine of t plus 1 is also equal to 1 minus sine of t over 1 minus sine of t squared. So we can cancel out 1 minus sine of t, and then what will remain is 1 over 1 minus sine of t. Okay, so this is now the derivative of dy over dx with respect to t. Okay, so following the formula for the second derivative, so substitute the derivative with respect to x of the first derivative is 1 over 1 minus sine of t. Okay, and then dx over dt is 1 minus sine of t. Okay, so therefore our second derivative is 1 over 1 minus sine of t squared. Okay, so that's it. So basically it's basically the first derivative is very straightforward. Okay, so while the second derivative may have a longer process. Okay, so but all you need to do is remember these formulas for the first and the second derivative. Okay, so I hope you have understood the lesson, and see you in the next videos. Good luck.